All right. So in general, based on the requirement, we have the following tasks. We have to program the robot so that it can perform its night duty based on the requirement. So in general, the robot will act like a scarecrow. So it will just stay there and it will sound an alarm if a nearby object is detected. So the object may be an animal or a human being. Should the object come closer, the robot should avoid the object. However, the robot should stay in the designated area. So first things first, we need the template. So in general, this is the overall set of functions that are needed in Arduino. And in our case, we have created several functions, user-defined functions, to make our uh, tasks easier. And we have created a template so that instead of typing everything over again, we'll just copy everything and put it in the new file. So I'll replace this with the template. So everything is there. Of course, you have to change the name in the program definition. So you have the variables, uh, storing the pin numbers, the setup, and after the loop function are the user-defined functions, which we can use in creating the program. Of course, the loop function will be empty. This is where we will write our main code. So first things first, uh, there are four things that the robot will do, but we'll ignore the first one since the robot will basically just stay still. And let's check the first one. The first one, the robot is supposed to sound an alarm if a nearby object is detected. The second is the robot will avoid the object. And the third is it will stay in the designated area after doing all of these things, or to make sure that the robot stays in the area. So what we can do is divide the program into three, and we can use comments to label our or label the section. For the first part, we'll label it as sound alarm. So we are going to write the code under or after this label. We'll make another label. We'll use avoid object. So all commands or code that the robot will need to avoid the object will be placed after this. And the third one is to stay. Everything that the robot should do to make sure that it stays in the designated area should be placed there. So we have three sections. So this would be our designated area. The robot should make sure that it stays here. So we are using a 9-volt battery. Let's check. So we have 9 volts. So this is connected to the ampere. I'll plug it in, connect the battery. There's no current program that is active. And let's start. Okay, so to do this, let's start with the first task, which is the most important since the robot is tasked to be a scarecrow during its night duty. It should sound an alarm if there is an object detected within its area. So we have beep. We can use beep. The beep function is found in underneath the loop function. And to use beep, we have to indicate the power. So to indicate the amount of power, we can use values 0 up to 255. I'll use 255 for maximum. And let's indicate the duration. Let's say 50 milliseconds. So that is based on the definition or how the function is declared here. And then I'm going to put a delay of 10 milliseconds so that if the beep is repeated, there will be a short duration of silence so that the beep will sound like a beep, not a continuous sound. Okay, however, I have to make sure that these two statements will only happen if there's an object or an object is detected by the robot. So I'll move this down and I will use an if statement. And I'll indent this. So line 34 and line 35 will only happen if the condition that is set here will become true. This is the start of this if statement. This is the end of the if statement. Everything between the open and close brackets will be dependent on the condition. And for the condition, we will use the sensor, the distance sensor, to find out if there's an object nearby. So I'll use the distance function to check if the object, or if there is an object that is less than 30 centimeters. Okay, so this is just a small setup. We'll use centimeters. Again, 2 and 4 are the pin numbers where the trigger and echo pins are connected to. And the distance function is one of the functions that you created in the earlier activities. So make sure that you finish the previous activities for you to understand the different functions that are found in this demo. Okay, the robot will sound an alarm if there's an object which is less than 30 centimeters in front of it. It will beep repeatedly. Well, it's a loop. The loop function is a loop. Therefore, everything in it will be performed repeatedly. So it will beep repeatedly. But before I move or proceed to the next task, let us test first if this will work. I'll check the settings. I'm going to upload. Okay, so let me just change. Okay. So I'll move my hand closer. Okay, so this means that the program is working. So the robot does sound an alarm whenever there is an object nearby, and we have set nearby as a value which is less than 30 centimeters. I can actually add blinking. I can do blink, or I can just switch LED on and switch it off afterwards. So let's check. Okay, so it does beep. So in this case, I have satisfied the condition that the robot should sound an alarm whenever there is an object nearby. Okay, so I'll leave this part and proceed to the next requirement. Now, if the object goes nearer, the robot will have to avoid. And the way it will avoid is it will move backwards. So I'll use another if statement, which will control whether or not the robot will move in reverse. So if distance is less than 10, meaning the object uh, after the robot has sounded the alarm still kept on coming. So I'll make the robot move in reverse. So reverse, I'll use 40%. I'll do a delay of 100 milliseconds after the robot moves in reverse, and after moving in reverse and waiting for 100 milliseconds, the robot will stop. So the movement backwards will be little by little. Okay, so let's check if this part of the code will work. I'll upload to the robot. Okay, let's check if this will work. So again, so the robot will sound an alarm if there is an object nearby. But if the object keeps on moving closer, the robot should move backwards. Okay, so the robot did move. Okay, so let's go back and check. So reverse 40, what is 40? Take note that I'm using a rechargeable battery. It's 9 volts. And I need to make sure that the power sent to the motors will not go below or above 6 volts. No, it should not go below 3 and should not go beyond 6 volts. And I'm saying here that I'll use 40% of the total power of the battery, which is 9 volts. And let's compute. So that will be 9 volts multiplied by 40%. So we are talking about 3.6 volts. Okay, so 3.6 volts. So the robot will move in reverse. However, remember that the third requirement is to make sure that the robot stays inside the area. So if the robot moves backwards, it will go out of the area. When this happens, the robot is supposed to go back in. Okay, so how are we going to do that? Because if the robot keeps on moving in reverse, it will end up outside the designated area. So let's go to the third section, which is uh, to make sure that the robot will stay. So how would the robot know if it's on the border? So we'll use the line trackers to check. So if left tracker is equal to 1, this means that the sensor is on a black line or a black or a dark surface. In this case, the only thing that is dark are the lines or the border. So what I want the robot to do is to go forward. I'll make it a bit faster at 45%. That would be around 4 volts. Okay, so it will move forward if the left tracker is on a black line. However, I want the robot to keep on moving forward. So instead of if, I will use while. So while or as long as the left line tracker is on a black line, I want it to move forward until the left tracker is equal to 0, meaning it's not on a black line anymore. I want the same thing to happen if the right tracker is equal to 1. So there are two things to check. As long as the left line tracker is on the black line, it should keep on moving forward. Afterwards, check if the right line tracker is on a black line, it should move forward as long as it detects the black line. So let's check if this will work. I will upload. Okay, so again, first task is for the robot to sound an alarm. Check. The robot should move backwards if the object goes near it. And third, the robot should uh, make sure it stays inside the area. All right. There. So the robot will make sure that it's in the area whenever it sees the black light. So in general, technically, I have finished uh, all the tasks or requirements. And at this point, what is needed to do or what is left for us to do is to make revisions on the code to make things better, to make the robot perform better. We have to do some tweaks. And one tweak that I see here is to make this section shorter. We can actually change the condition since these two while statements will do the same thing. I'll change the condition so that it will check for two things. One, if the left tracker is equal to 1. The second one is for if the right tracker is also equal to 1. This means or, and it reads as left tracker is equal to 1 or right tracker is equal to 1, whichever of the two. No? As long as one of the two is 1 or returns 1, it should move forward or keep on moving forward. And Of course, I'll remove the second while, since this while here will check for both. Let's check if this will work. I'm going to upload again. Okay, so first task, second task, third task. All right, I can actually improve this by increasing the amount of time that it goes forward. Let's check again. So, so this looks better since the robot is more of inside than outside. And we can further improve this by moving the statements outside of the loop function and create a function of their own. So I will uh, group the statements and name it as sound alarm. So this group of statements will be called sound alarm. Instead of uh, putting those lines here, I will simply call the function name sound alarm. This will be placed uh, in a function of its own, and I will call it avoid object. Here, and this one will be moved as well, and I will name the function state. Okay, so looking at the main program, uh, this is easier to read, although there's really no need to move those statements and come up with their own functions since they are actually short. However, this is just to demonstrate that it is always easier if you will organize your code and put them in their own functions so that you can uh, easily read or organize or debug your main program. And as you can see, uh, by simply looking at the loop function, you would know that the robot will do three things: sound an alarm, avoid the object, and stay. So all of these will be repeated over and over again while the robot has power. And this is done repeatedly or automatically since that is the purpose of the loop function. And that is why the loop function is named loop. Now, in case you don't have a battery, let us check how much power can be used from coming from the USB port. So power is 5 volts, goes into the microcontroller and goes out via V in. And are we going to get still 5 volts? Let us check how much power is available. So we are looking at 3.7 3.7 volts. The same thing, same amount, actually the same amount of power will be made available to your motors if you use a power bank. Okay, so please take note that if you use the power bank and you connect the power bank to the microcontroller, only 3.8 volts will be made available. So you can use the mini USB cable that came with your kit to connect the power bank to the USB port. So again, 3.7 or 3.8. Okay. Can we actually make the robot move with that amount of power? Let us check. Let's go to avoid object and stay. So you have reverse 40%. However, please take note that we only have 3.8 volts available. Unlike before, we had 9 volts because we disconnected the battery. Just for demonstration purposes, I'll make the robot move using USB power or whatever is left for the motor driver. So what is 40% of 3.8 volts? So if you're going to check what is 40%, so 3.8 volts multiplied by 40%. So I'm talking about 1.5 volts. So again, 3.8 times 0.4 is 1.5 volts, which is very low because the motors are rated 3 to 6 volts. So we have to make sure that the actual value or the voltage will not go outside that range. So I cannot use 40 because 40% is just 1.5 volts. But since the total amount of power is 3.8 volts, I can actually say here that I want the robot to move using 90% of what is available. And what is available is 3.8 volts. And for stay, I will make the robot use 100% of whatever power is available, which is maximum of 3.8 volts. Okay, will the robot move? Let's check. It's uploading. Okay, let's check. So it will beep, will move back. Okay. However, it's not that fast because there's not much power. We can further improve this by adding more power. So maybe I'll just use 100% for reverse. I'll upload. And check again. So it should move back. Okay, so it's a little bit faster this time. All right. We can further improve this by changing the delay so that there will be more momentum for the motor because it basically moves a little and then afterwards stop before it is asked to move again. So if I'll make the movement a little bit longer, maybe this will improve. So I'll upload. And let's check. Okay, so this is better. So if you will remove the connection and use a power bank instead, you will get the same result. And let's check if it will move forward. It does move forward. Okay, so that's it. So you only do that if you don't have a battery pack or a power supply. However, recommended is 7 to 12 volts. But in this case, we have no choice but to make use of what is available coming from the USB port. And 5 volts go in and goes out on the other end. For the motor driver, there will be a voltage drop of 3.8 volts. For a longer or better explanation or demonstration, please watch the video on how to supply power to the robot. So that's it for now. Thank you.